My name is Jackson Sweeney, and today I'm going to be teaching you all about the classification and identification of first-order ordinary differential equations. So first, before I begin, we need to understand some definitions. First of all, a first-order differential equation basically means that the highest derivative in the equation is a first derivative. Next, an ordinary differential equation means that the equation contains only ordinary derivatives. And lastly, a linear differential equation means that the variables in the equation have a power of 1 and all variables are multiplied by constants. So a linear first-order ordinary differential equation is going to have the form of dy dx plus p of xy equals q of x, where p and q are both functions of x. So now we know how to classify a first-order ordinary differential equation and whether it is linear or nonlinear. Let's look at some solution techniques. First of all, we have separation of variables, which will work for both linear or nonlinear first-order ODEs. Next, we have the integrating factor method, which will work for linear first-order ODEs only. Next, we have the method of undetermined coefficients, which works for linear first-order ODEs that have constant coefficients. And lastly, we have the Bernoulli substitution, which takes a nonlinear ODE and turns it linear. So now we know these solution techniques, let's implement our knowledge with some practice problems. So looking at this first equation, what would be the best solution technique to solve this? Well, I would say the integrating factor method, because this coefficient is not constant, so we cannot use the method of undetermined coefficients, and it is a linear ODE, so integrating factor method would work best. Next, we have here, number 2, and this is nonlinear, so we could either use Bernoulli or separation of variables. For this problem, separation of variables is going to work best, because you can see that it is easily separable to get all the x's on one side and the y's on the other side. Next, we have number 3. And what's odd about this one, it has this y squared out here, which means that it is nonlinear. Now, looking at this, Bernoulli is going to be our best option to solve this, because it is not easily separable into x's on one side and y's on the other side. And that will take this equation and turn it linear, and then it can be solved using any of the other solution techniques. And then lastly, we have problem number 4. And looking at this, I can see that this is a linear ordinary differential equation with constant coefficients. So this means that we can use the method of undetermined coefficients to solve this. Thank you for joining me. Have a good rest of your day.